Hello and welcome to this episode of Microchips, and today we're looking at this very poorly Superstar 2400. Yes, I know it doesn't look like a Superstar 2400, it should look like this. But we're never going to get it to look like that ever again, because trying to find a front for this will be near enough impossible. So we're going to have to make do with what we've got. But anyway, before we start, don't forget to like, subscribe, share, comment, join the Facebook group and all that. And let's get started. So I bought this radio as scrap, basically, parts, with a view to just using it for bits, but you know me, I always like to try and get them working. So with a little bit of messing about, we did actually get this working. And as you can see, it's a PCM A001S board, but this is the 3 crystal version that uses the 2 wafers. Now somebody's actually added an extra crystal into this. Not sure why they've done that, but that's not the problem. So yeah, it uses 2 different sets of encodes, this radio. So 3 crystals, 6 bands, 2 sets of encodes. Big problems for my modification boards. So we got this radio working anyway, popped one of my volt feed VCOs in, and the radio actually sounds good. It just needs a bit of modification. So what we're doing is we're just working out which of these terminals now corresponds to which set of encodes we're going to use. So like I said, we've got 3 crystals, 6 bands, we've got 2 wafers on the channel change. So on the band select, I'm expecting to see some form of alternate jump wire to go between the different bands as it switches them. So just working out which of these wafers I actually need to use for my modification. But it should be simple enough. So buried deep inside there is the PLL chip. Not a lot of space. And there's our PLL chip. Just a standard PLL 02A in this one. So we'll take that out. Because I'm going to be modifying one of my 5KC boards, we're going to have to put a PLL 02AG in. I think that will be the best for this radio. Give it a lot more functionality. So there's my 5KC board with a bodge wire on it for the extra binary line that we needed. So I've got some more boards on order. So we're just going to be using my test board for this. Unfortunately, it gave me a few problems due to the high band not being on the standard 255 encode. It was on the 210 encode. So channel 1 midband or encode 255 should all be 1s, which it is there. So that is absolutely correct. And we change to another band, and then we get the encode of 210. Which it is. So my board needs to understand both of these sets of encodes plus UK40 off one of the sets. So after a bit of testing, it all went well. And this is a few weeks later when my new boards have appeared. So we'll take out my test board with its bodge wire. Now these were on IC sockets, which made it quite a bit of a tight fit in front of those capacitors. So I know we should never do this, solder a PLL directly onto the board, but I have done on this one. Slims it down just a little bit It doesn't cause any stress on those capacitors. So there's my new board in place with its new programming. Now we're going to deal with this relay. Now this should have a beep in there, and somebody's removed it, so we need to try and do something with that. So we just need to work out which is positive and negative on this strangely configured relay. The pinouts aren't what I'm used to for this style of relay, but we work out that it's just switching transmit and receive basically through a negative switching on the microphone socket. So as soon as we know which is receive and transmit, we can actually remove this relay and fit something a little bit more fitting, should we say. So the yellow wire there is receive, the white wires are transmit, and the black wires are common. Easy as that. So I've added a few extra wires for the PTT and the audio. Now luckily they've left us the bracket. So what we've done is we've made a copy of the original beep that should have been in this radio, but we've actually changed it so it sounds a little bit more like a NATO style bleep. So we enable a bleep with 8 volts. And it's pretty close to a NATO beep, pretty close in time and frequency. So yeah, happy with that. So there it is fitted, with a little bit of the wiring tidied up, and we've got a wire that we can bring to the front panel to switch the beep on and off. So we have our wires, quite a few of them now, but it's coming together. So there's our switches we're going to be using. So we're going to repurpose the NB, ANL and CBPA switches. So we just need to decipher which connections to go to, what needs to be connected, and any wires that don't need to be connected I've pulled back so can be tidily removed from the board. So there's our switches. I put some switch cleaner in, a bit of lubricant. Looking good. So there's our first switch, which will be the beep on and off. Now the other two switches will be plus 10 kc for the skip channels and minus 5 kc to drop down to zeros. Even though the kc shift goes that far, just a nice feature to have. So there's our switches refitted. Looking better already. Now here's the band switch, and there's the alternate jump links as what I thought it was going to be. So alternating the green and yellow wire for the bands to switch in the different wafers. So we just need to work out which of these wires is going to be the high band wire. And we need to work out which wafer we're going to be on. It looks like we're going to be running off the green wafer. This orange wire, that's the high band. And the two end connections there, that's the super high and super high. So what we're going to do is we're going to add a Schottky diode, connecting the 2 times high to the high band, so it will enable high band crystal on the last selection. And we're adding a 10k resistor for the UK40 selection on my mod board, because there's roughly 9 volts on this, so the 10k will drop it down to a safe voltage for my PIC chip. So let's have a look. So there's super low, onto low band, onto mid band, onto high band, onto super high band, and last one is the UK40, still on the 5s. Move the KC shift down, and that brings us onto the UK frequencies. Now I could fit an offset in there, but it doesn't bother me turning the KC shift. So let's have a look at this Synad stuff that we always like to look at. So minus 110 dB. Yep, that's fine. Don't need to start lecturing on all these microvolts for this and microvolts for that. Yeah, whatever. For about minus 110 dB, if it's showing 20 on the scale, it's good enough for me. So let's rebuild the radio. So we'll put the front back on. Now, did you really think that I was going to leave this front on it? No. This is not staying on it. But what we do have is somebody give me a Superstar 2000 front that's a little bit battered, but our friends over at Print Extreme took the metalwork and made a nice custom decal for me. So I know it's not the correct front for the radio, but I think it looks a damn sight better than what it did originally. So all in all, very happy with this. I know it doesn't look like what the Superstar 2400 should look like, but for me, this has saved another radio from the scrap. There's one thing I don't like, is that channel change button. It is horrible. There's absolutely zero grip on it. So there's our beep, and I'll switch my NATO 2000 on. You can hear the it's really close. So we're going to get the cases powder coated, and that'll be it. So anyway, don't forget to like, subscribe, join the Facebook group, buy me a coffee, join Patreon, and we'll see you in the next video.